They need the right information to do that, okay? But the DNA is not deciding that. The environment is telling the DNA what genes to use. So the beliefs on the human level or the environment of the cell are altering the biology of the cell. Another experiment is with stem cells. Those are genetically identical, just like twins. They're twin cells. Everything's the same about them genetically. He took them and he put them in different petri dishes. So you have 3 dishes, identical cells in every dish, but you add different nutrients to each dish, okay? So each group of cells has a different environment. And what you get out of that, one of the dishes turned into bone cells, one turned into muscle cells, one turned into fat cells. Identically, genetically identical, different environment, 3 different cell types made, okay? They're working on the Human Epigenome Project now. You thought the Genome Project was big. This has already started in Europe. You're talking about millions of possible marks on the DNA to take those 25,000 genes, make 120,000 proteins. On top of that, change with response to the environment and hand that information on to the offspring. So it's a huge project. Here's another very profound experiment. These 2 mice are genetically identical. They both carry a mutation in this agouti gene, and that mutation causes obesity, turns the coat yellow like this, causes some cancers, causes diabetes. The only difference, okay, genetically identical. This mouse, the mother, was given extra B vitamins when the mouse was in utero. The mouse is born, it's healthy, it's normal, the coat's normal, the weight's normal. There's no extra disease risk. Simply by adding in a diet rich in B vitamins, they've shut down this agouti gene. The mutation has been overridden by the environment. That's a very important experiment to see, because when we're taking LifePak Nano, we're taking vitamins. You can see how profound just a series of B vitamins is. It's critical to put the right nutrition in your body because it is talking to your genes and causing gene expression one way or the other. So the authors are Yertle and Waterland at Duke University. Everything I'm showing you has been done at major universities. It's all published. You can see any of this. With no more than a change in diet, laboratory agouti mice were prompted to give birth to young that differed markedly in appearance and disease susceptibility. And what's amazing, the author himself wrote, it was a little eerie and a little scary to see how something as subtle as a nutritional change in the pregnant mother mouse could have such dramatic impact on the gene expression of the baby. The results showed how important epigenetic changes could be. This is a very big thing for you to see, because in Nu Skin, that's what enables us to do what we're doing, okay? Another experiment, this is a simple one, but it's very dramatic. Cells in a petri dish, if you put some nutrients on one end of the petri dish and you put toxins on a different petri dish, same cells, over time, these group of cells will migrate towards those nutrients. These group of cells will move away from toxins, from the negative signals. Another important point, though, is they can't go both ways at once. Cells are either moving in a direction towards a positive stimulus, towards nutrition, or they're moving in protection from a negative signal, something that's toxic to them, okay? But it's one or the other. They're either in protection or growth. You don't get both at the same time. So in terms of a cell, its behavior is either attracted towards a positive in growth or repulsed from a negative in protection. So when the cell, and all I'm doing is giving example after example how cells deal with their environment. And that determines what genes they then use, okay? When confronted with environmental signals, cells have to make a decision to be in growth or protection. When the cell is in protection, it stops growing. And you can see that on the human level. when, you know, the viscera of our body is where the growth is, the major organs are here, digestion, everything. When a person goes into a fight or flight response, the blood gets sent out to the extremities. It needs to be used in the muscles to escape from a situation or to fight or to deal with, however the situation's dealt with. But the blood is pulled from the viscera. Growth stops when that other response is happening, okay? They don't happen at the same time. And that's a perception. The more protection we think we need, see, it's in here, what we think we need, the more we shut off our growth mechanisms. Cells are either moving in growth or protection, but they can't do both at the same time. And that's the same on a human level. I was saying before, we're a community of cells. We're either growing in attraction toward a positive, which is love actually, or repulsed in a fear in protection. It's one or the other. And they've shown scientifically the most important growth promoting signal for a human is love. It's more important than nutrition. There's studies on orphanages in Europe where the children are given all the nutrition they need, but they're not given the love that they wanted from the parents, and they don't grow as well. When you're in love, you're enhancing growth mechanisms. When you're in fear, you're shutting down growth mechanisms. But the bottom line is it's one way or the other. And you hear that in Nu Skin a lot. You're either growing or you're receding, or, you know, people have their different quotes. But I'm showing you why it's true scientifically. There's a quote I found from Lou Holtz, who's a coach and an inspirational speaker. In this world, you're either growing or dying, so get in motion and grow. My point here is there's no status quo on the cellular level and therefore on the human level. You're either growing or you're going backwards, but you cannot just exist as you are and think you're sustaining that level. You're not. You're in motion. Human body is in flux all the time, and I'm going to show you that at the DNA level. So then the question is, what beliefs are you selecting genes with? If your beliefs in your head are off, you can select genes inside your body that are inappropriate to that environment. It's up to your belief system. So how you see the world genuinely is how you are. It has nothing to do with the world. It has to do with you, inside you. And that's why we do a lot of this work on ourselves in Nu Skin. It's our perception that determines everything. Determines gene expression. There's new studies coming out, I was just reading, that when people are looking at a situation, based on how they're perceiving it, their vision literally starts to change. When people are kicking field goals, they took a group of people. The people that are doing well, they actually started seeing the goalposts as wider. And the people that were missing more started seeing the goalposts as closer together. Literally, within minutes of doing it, their vision was changing. Their perception of their world was changing. A great master once said, the mind is the power. That's very true. More true than a simple interpretation. And I'm showing you why on the cellular level. But the bottom line is epigenetics means you have the power to change anything by changing your beliefs. That includes what you put into your body, including diet, supplementation, thoughts. You're not a victim of your DNA. And that's the big takeaway here. I don't know if you know this, 90%, 95% of all cancers people experience have no hereditary linkage. So you hear things a lot in the media about this cancer gene and that cancer gene, and is it genetic, and that can be a component. Mostly it isn't, you can see, but it can be. But you have to ask yourself, person is healthy for 40, 45 years and turns up with a cancer and they say it's genetic. Well, why didn't they have cancer for 40 or 45 years? That gene alone is not sufficient to give a person cancer. Something changed in their environment because they carried the gene all along and they were healthy. You have to rethink some things. Have you heard of Alfred Russel Wallace?
Yeah.
Have you heard of Charles Darwin?
Yes.
So Alfred Russel Wallace, they just made a stamp in 2010 of the Royal Mail in the United Kingdom to this man, an evolution. And I'll show you why. He wrote a manuscript and he sent it to Charles Darwin It was called On the Tendency of Varieties to Depart Indefinitely from the Original Type. He had a completed manuscript on his theory of evolution. 1 month later, see, Darwin had been putting thoughts together for about 20 years, but he didn't have it formulated yet. The Darwin-Wallace theory got introduced at this Linnaeus Society in London in 1858. And why is this important is my question. Well, they both were looking at the same data, and it got called natural selection at some point, how the environment affects a population for its evolution. But from Wallace's point of view, he felt evolution was driven by elimination of the weakest. Darwin interpreted the data to mean that evolution resulted from the will to survive inherent in the fittest. Do you see, those are two very different statements. That became survival of the fittest. Survival of the fittest means a couple of the top dogs make it. There's not enough resources to go around, and everyone fights to be the best, and those strong ones reproduce, and that's how evolution happens. There's a completely different way to interpret the data. And Darwin and Wallace's version was that evolution eliminates the weakest of the species, not selects for the fittest. What that means is, in his mind, we improve in order to not be the weakest. In Darwin's world, everybody struggles and fights to be the best, so it's much more based on competition. Wallace's theory was based on cooperation, and that everybody can work together and everybody can improve themselves to be a stronger member of the species. You see the difference? That's what I'm telling you, is that through epigenetics, through what you put in your body, what you put on your body, you have an evolutionary right, if you will, to be better. You know, the weak don't stay weak. There's a lot more politics to this, and they actually remain friends. And later in his life, Darwin came around to actually more of a Lamarckian view, which is a whole nother talk. But what I just showed you, how the epigenetic marks are passed on from generation to generation. In strict Darwinism, that's not possible. They would say you have to have a spontaneous mutation, which occurs at a very low frequency, and that's how species start to change. But there's a completely different view, and I just gave you several examples that even as a child, how that child is eating is affecting his grandchildren. So that's not a genetic mutation. That is literally the environment affecting an individual, and that individual passing down that information. So it happens a lot quicker. So what I'm saying is, survival of the fittest is only one interpretation of natural selection. The only reason I'm bringing this up is because, whether you know it or not, it's in your psyche, because our world and our media is very much survival of the fittest, Darwinism, you know, only a few make it, and whatever signals you've personally gotten. That's only one way to look at that data. The other way is that everyone can grow and become stronger. And that's why Nu Skin works, because everybody's body is just taking environmental information and using its DNA accordingly. So now we get to this age lock algorithm, and this is really the key to why we can do what we can do and no one else can. The basics of an algorithm is just a step-by-step problem-solving procedure. It has a finite number of steps to get you to an answer. Some of you have heard the word algorithm before, right? If you've studied any kind of math, you know, several levels of math up, you'll hear about algorithms. Algorithms, the example Joe Chang gives are, Google has a phenomenal algorithm to search the internet quickly and accurately. What that allows Google to do is dominate the search engine market. Most people, when they think of I need to do a search, go to Google because they have the best algorithm, okay? Now we talk about the age lock algorithm. There's 3 components to it. Identify. We're talking about identifying genes